You flip a light switch, and a bulb across the room lights up instantly. You plug in your phone, and electricity flows through the cable. You've been told that electrons move through wires like water through pipes, carrying energy from the power plant to your home. But here's the thing. That's not what's happening. The electrons barely move at all. They drift slowly about a millimeter per second in typical household wiring. If electricity were actually electrons flowing like water, it would take hours for anything to happen when you flip a switch. So what's really going on? The answer is far stranger and more beautiful than the simple story you were taught. Electricity isn't about particles flowing. It's about fields. It's about forces propagating through space at nearly the speed of light. And it's a manifestation of one of the most powerful forces in nature, a force so strong that it makes gravity look like nothing. Let me start with something Feynman loved to point out. The electrical force is absurdly strong, about a billion 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 times stronger than gravity. That's not a typo. That's a 1 with 36 zeros after it. And yet, you don't notice it. You're not being violently repelled by every object around you. Why? Because matter is electrically neutral. Every atom has equal numbers of protons and electrons, positive and negative charges that balance out almost perfectly. The electrical forces cancel. But imagine they didn't. Feynman used to ask, what if you had just 1% more electrons than protons in your body, and someone else standing an arm's length away had 1% more protons than electrons? The repelling force between you would be enough to lift a weight equal to the entire Earth, not a mountain, not a continent, the entire planet. That's how powerful the electrical force is. And it's lurking everywhere, hidden by the fact that charges cancel so precisely. Subscribe and like for more videos that explain what's really happening beneath the surface, because what we're about to uncover will change how you see every wire, every circuit, every device in your life. Now, back to the light switch. You flip it, and the bulb lights up almost instantly. But if electrons drift at a millimeter per second, how does the signal reach the bulb so fast? The answer is that the signal isn't carried by electrons moving. It's carried by the electromagnetic field. When you close the switch, you change the electric field in the wire. That change propagates as a wave, an electromagnetic wave, traveling at nearly the speed of light. The electrons in the wire respond to that field and start drifting. But the energy, the signal, the thing that makes the bulb light up, that's traveling through the field, not through the particles. Think of it like a long tube filled with marbles. If you push a marble in one end, a marble pops out the other end almost instantly, even though no individual marble traveled the full length of the tube. The push propagates through the chain. In a wire, the electromagnetic field is the push, and the electrons are the marbles. The field does the work. The electrons just respond. Here's the deeper insight. Electricity isn't a thing. It's a manifestation of the electromagnetic force, one of the 4 fundamental forces of nature. And the electromagnetic force is mediated by the electromagnetic field, which exists everywhere in space, whether or not there are charges around to feel it. When charges are present, they create disturbances in the field. Those disturbances propagate as waves. When they hit other charges, they exert forces. That's what electricity is: interactions between charges through the electromagnetic field. Feynman emphasized this relentlessly. You can't understand electricity by thinking of it as a fluid or a substance. It's not stuff flowing through wires. It's fields and forces. The wire guides the field, shapes it, channels it. But the energy travels in the field surrounding the wire, not inside it. In fact, most of the energy in a power line is carried in the electromagnetic field outside the conductor, not in the motion of electrons inside. Let's go deeper. What is an electric field? It's the property of space that exerts a force on a charged particle. If you place an electron somewhere, it feels a force if there's an electric field at that location. The field is real. It has energy. It has momentum. It can do work. It's not just a mathematical convenience, it's a physical thing. And here's where it gets truly strange. The field exists even when there are no charges around. The vacuum isn't empty. It's filled with electromagnetic fields, constantly fluctuating due to quantum mechanics. Virtual photons, the particles that mediate the electromagnetic force, are popping in and out of existence all the time. The field is alive, active, even in what we call empty space. Now, here's something most people never realize. The reason you don't fall through the floor isn't gravity holding you up. It's the electromagnetic force. The atoms in your body and the atoms in the floor have electrons on their outer shells. Those electrons repel each other through the electromagnetic force. You're not touching the floor in any classical sense. You're being held up by electrical repulsion. Every time you touch something, you're feeling the electromagnetic force, preventing atoms from occupying the same space. Solidity is an electromagnetic phenomenon. And here's the philosophical kicker. Electricity doesn't exist as a separate thing. There's no substance called electricity distinct from matter and fields. There's the electromagnetic field, there are charged particles, and there are the interactions between them. When we say electricity, we're talking about particular configurations of those interactions, charges moving, fields changing, energy propagating. It's not a thing. It's a process. Feynman would tell you this. Nature doesn't owe you an intuitive picture. Your brain evolved to throw rocks and climb trees, not to understand electromagnetic fields. The fact that electricity behaves this way, that energy travels through fields, that forces propagate at the speed of light, that particles barely move while signals fly shouldn't surprise you. Nature does what nature does. Our job is to figure it out, not to demand it make sense according to our everyday experience. And once you accept that, once you stop trying to force electricity into the mental model of flowing water, it becomes far more interesting. Electricity is fields in motion. It's energy propagating through space. It's the electromagnetic force, stronger than anything you can imagine, hidden by the precise balance of charges in matter, revealing itself only when we break that balance and let the fields do their work. So when you flip that light switch, you're not sending electrons racing through wires. You're disturbing an electromagnetic field. That disturbance propagates at nearly the speed of light, reaching the bulb in a fraction of a second. The electrons in the bulb respond to the field. Energy is converted to light, and you see the result. The electrons barely moved. The field did everything. That's the truth about electricity. It's not what flows through wires. It's what makes the universe work at the most fundamental level. And the fact that we've harnessed it, that we can control it, that we can use it to power civilization, that's one of the great achievements of human understanding. But only if we understand it correctly. Not as a substance, but as a manifestation of the fundamental forces and fields that govern reality itself.